Hey everyone, in this video we're going to talk about how to use the process of logarithmic differentiation to help us simplify the process in which we would take a derivative. So in this case here we have something like y equals x raised to the x power. And so a nice easy way for us to be able to take this derivative is actually to take the logarithm of both sides. So I'm going to turn each side into a natural log. So we're going to say that the natural log of y is equal to the natural log of x raised to the x power. And we know from our logarithm properties that that exponent we can actually just take out and put right in front of the natural log. So really what we have now is the natural log of y is equal to x times the natural log of x. And so what we're going to do now, since we know how to take the derivative of a natural log, is we're just going to differentiate on both sides. So d dx of the natural log of y equals d dx of x times the natural log of x. And so on this left side, it comes out to be pretty easy. I know the natural log of y is going to have the derivative 1 over y dy dx. And on the right side over here, I am going to have to use the product rule a little bit here. So we have x times the natural log of x. So that's going to be the first term times the derivative of the second term, which would be 1 over x, plus the second term, natural log of x, times the derivative of the first term, which would just be 1. So if we simplify this out a little bit, we're going to get 1 over y is equal to, 1 over y dy dx, I should say, is equal to x times 1 over x, which is really just 1, plus 1 times the natural log of x, which is just the natural log of x. And we'll go ahead and we'll get dy dx by itself, so we'll multiply both sides by y. And so we can say that dy dx is equal to y times x plus the natural log of x. But remember, we already know what y is. Y is actually equal to x to the power of x. So I'm going to go ahead and rewrite this up here where I have a little bit of room and say that dy dx is equal to x to the x power times x plus the natural log of x. So by taking the derivative of both sides, after turning them into natural logs, I was able to kind of simplify my process a little bit. It was easy to get this x right here out of the exponent and down to where I could use the product rule. So kind of the process to use logarithmic differentiation is usually to take the natural log of both sides, remove any exponents that need to be moved down so that we can use the product rule. Then we differentiate both sides, and you try to get dy dx by itself. And if you end up with something like this where you have a y term on the right side of the equation, you're just going to go ahead and replace it with whatever it equaled right here at the beginning. So let's take a look at one more example of this. So let's say we had something like y is equal to x raised to the tangent of x power. So again, the first step is to take the natural log of both sides. So the natural log of y is equal to the natural log of x raised to the tangent of x power. And just like before, we want to take this exponent and bring it down in front of the natural log. So we're going to say now that the natural log of y is equal to the tangent of x times the natural log of x. And we're going to go ahead and differentiate on both sides now. So d dx of the natural log of y is equal to d dx of the tangent of x times the natural log of x. And so once again, we see that, all right, on the left side, the derivative is fairly straightforward. On the right side, we're going to have to use the product rule. So derivative of natural log of y is just going to be that 1 over y dy dx. And on the right side, we're going to have tangent of x times the derivative, which would be 1 over x, plus natural log of x times the derivative of the tangent, which would be the secant squared x, And so we end up with this big long thing on the right side. And now once again we're going to multiply both sides of this equation times y. So it cancels out on the left, and I have this whole thing times y. But remember, we know what y is. Y was x to the tangent of x. So our final answer, I'm going to go right back up top here where we have a little bit of room, and say that dy dx is equal to, we'll put this whole thing in brackets, and it's going to be tangent of x over x plus the natural log of x times the secant squared of x, and that's the whole thing's going to be multiplied by x to the tangent of x power. I'm running out of room over here. Let's see if I can't just move this all over a little bit. We'll just slide that over, and so it's x to the tangent of x power. And so this big long piece right here actually ends up being the derivative of this circle equation over here. So you can see the logarithmic differentiation definitely has its challenges, but it helps by taking something like the tangent of x or the x power out of an exponent and moving it down to where we can use the product rule. I hope this helps, and I will see you in the next video. Good luck.